Okay, greetings ICampSA learners, and welcome to another awesome edition. In this edition, we are looking at grade 12 mathematics, sequences and series, but our focus for this part will be on arithmetic patterns. And as you study, you will realize that there's many terms that they will use synonymously with arithmetic patterns. You will hear others saying linear sequence, others will say linear pattern. You'll hear others saying linear series or arithmetic series. We are all talking about the same thing. The minor difference is that when it is a series, we just have a summation. And when it's a pattern, it is what we are used to, separated by commas at times. So let's get to it. By the time you finish going over this course, you should be able to understand the fundamentals. So you should be able to identify the first term of a series, be able to also calculate the common difference in any given sequence. You should be able to define and also list the properties of arithmetic sequences and series. Secondly, you should be able to work with terms of a sequence. So if you are asked to determine Tn, the general formula, you should be able to calculate it. If you are asked to determine, let's say, T7, you should be able to find it using the common difference. Thirdly, or number 3, by the time you finish this course, you should be able to apply summation techniques. So you should be able to use the formulas to calculate the sum of n terms. And also, very importantly, you should be able to use your sigma notation. So if you are given a series and you are asked to represent it in sigma notation, by the time you finish this course, you will be able to do that. Number 4, you will develop your problem-solving skills. So you'll be able to solve exam-type problems because as part of this course, we will be doing problems from past exam papers to help you to understand sequences and series even better, specifically arithmetic sequence in this instance. Number 5, which is the last point, you should be able to demonstrate mastery through application. So you should be able to interpret problems by yourself, present the solutions clearly, and that is very important because it's one thing to understand, but it's one thing to show the person who's marking that you understand, so that you will be able to achieve by the time you finish this course. You'll be able to present your solutions clearly and demonstrate confidence and understanding of the concepts. So next, let's jump into what an arithmetic sequence is. But where I want to begin is by reminding you that an arithmetic sequence is also referred to as a linear sequence. So what you should realize is that when you hear a linear sequence, you should remember from your early years, I believe that should have been grade 9, that whenever we are speaking about something that is linear or a linear sequence, back in grade 9, you would have Tn equals an plus b, like this. So our series will fundamentally look this way. If you do remember, this is something which we did back in grade 8 and 9. But what I want to bring to your attention is 3 important formulas that you need to understand when we are talking about arithmetic sequences. The first formula which you need to be aware of is the formula that describes the general term. And what you need to understand is the general term for our course will refer to it as Tn. So the general term is given by this expression here. So our Tn is given by a plus n minus 1 times d. And we need to ask ourselves, what is the a and what is the d? So what you should know is that a equals T1, of which this is the first term of the sequence or series. And then d is what we refer to as the common difference. And specifically, it is the first difference. The question we need to ask ourselves is, how do we get this d, which is the common difference? So d will always be the difference between two consecutive terms. So d will be t2 minus t1, and we'll get the same answer as when we do t3 minus t2. And if we go to t7, we'll minus t6. So as long as it is two consecutive terms, if we go to t99, it means we would need to minus t88 in order for us to, t98 in order for us to find d. So essentially d is the difference between any two consecutive terms. Let's have a look at the second most important formula, because we said there's three of them. And this is the sum of terms formula. And what you will see is, for the part of this course, whenever we're referring to the sum of terms, we'll use Sn, which is just the sum of n terms. And how you find the sum of n terms, you will use this formula. You'll have n over 2 into 2 times a plus n minus 1 times d. Okay? Where your n will be the number of terms that you are summing, and then a and d will be as defined above, where a will be the first term and d will be the common difference, which is just the difference of any two consecutive terms. And then let's have a look at number 3, because we said there's 3 important formulas. And on number 3, we're still looking at the sum of terms. And for this one, we are using a slightly different formula, which is the sum of terms will be n over 2 into a plus l. What you need to note here is that the l is the last term of the sequence. So essentially, we'll use the second equation, which is a plus l, when we have the last term of the sequence and the first term of the sequence, which is a. So what we need to do next is to quickly explore the general term of an arithmetic sequence. There's some properties which we need to extract, and I want you to see them so that they stick. So if you do remember, you should remember that our general term Tn is given as a plus n minus 1 times d. So what I'm going to do is to determine the first 4 terms of the series of the sequence. So let's start by looking at T1. So if we want T1, it means wherever we go and see n, we must substitute n is 1. So if you look at our equation above, wherever we see n, we put in 1. So what we'll end up having is a plus 0 times d, which will just be a. So what can we say here, and what do we see? What we can say and see is that our T1 is always a, which means our a is always equal to the first term of the series or sequence. Okay, that is a very important observation. Let's make our face to even smile better. So that is very important for you guys to note, that whenever we are dealing with an arithmetic sequence, the a, or the first term, is always equal to a. So meaning you can already go and find what this is. Okay. Now let's go and have a look at T2. So what T2 means is wherever we see n, we put in 2 on that original or general term. So we'll just have a plus 2 minus 1 times d, and you will see the answer is a plus d. So that is T2. Let's go and have a look at T3. T3 will just take n and make it to be 3. So what we will have is a plus 3 minus 1 times d, of which the answer will be a plus 2d. Then let's go and have a look at term 4, because we said we will need 4 terms. So at term 4, we take n, we make it to be 4, which means we'll have a plus 4 minus 1 times d, and this will end up giving us a plus 3d. So now that we have our terms, we are going to put them in a sequence order. And then we'll start exploring some properties that we need to take away. So essentially what we will do is we'll have T1, and then we'll have T2, and then T3, and then T4, and so on. The other terms we are not going to put in. So let's go ahead and put these terms as listed here. So for T1, we have A, then we have A plus D, then we have A plus 2D, and then we have A plus 3D. So what you need to observe is that the first term, A, or the first term will always be equal to A. So T1 will always be equal to A. This is very important for us to make a note of. So I'll put in a star. Then let's start looking at the differences, okay? So let's take this one minus this one. So if you observe carefully, A plus D minus D, you will see that the answer will be, A plus D minus the first term, which is A, you will see that the answer becomes D. Let's go and do it with the second term. So if you observe carefully, we'll have A plus 2D minus A plus D. If you do the maths here, you will see the A's will cancel, and the answer which will be left will be D. Then let's go and deal with the third one. So if we take this difference here, what you will see is that we'll have A plus 3D minus A plus 2D. And the answer which you will see is that we will have a D. So what does this tell us? If you observe carefully, we have a common first difference, D, D, D. So meaning regardless of the two consecutive terms that you are subtracting, we will always get D. So that is the observation which we have made. In conclusion, our takeaway from this exercise is that the arithmetic sequence has the same first difference. And this first difference is known as the common difference, and it is equal to D. This is what we were speaking about. So next, let's go and explore the summation. So the sum of terms we have spoken about before, and we mentioned that the equation is given by n over 2 into 2a plus n minus 1 times d. And then we also mentioned that there's another equation where we can have n over 2 into a plus l, which is the last term. And this will also give us the sum of n terms. So remember, what we are looking for here is the sum of n terms. So if you look at these equations, you should ask yourself, what do we need in order for us to determine the sum of terms of n terms? What you should see, we need the value of a, we need the number of terms n, and we need the value of d. And if we're using the other equation, we need the last term. So once we have established all of these quantities which we need, we can now therefore go and find the sum. And on top of this, there's something I want to introduce you to, which is called sigma notation. So what is happening with sigma notation is we can express a sum of a series in sigma notation. So sigma notation is just another way to express the sum of terms of a series. So this means if they do ask us a question where we are required to take a series and then express it in sigma notation, we should be able to do that, because all what sigma notation is, it is another way to express the sum of terms of a sequence or a series. So whenever we are required to express a sequence in what you call it, in sigma notation, for example, if you remember, we had 4 terms that we found. So I'll just go and copy them and then just show you this in application. So with these 4 terms which we found before, and what we can do is we are going to make them a series by just putting a plus in between. So if you look at this, how we can express it in sigma notation is we are just summing. If you remember, this is T1 and this term here is T2, this is T3, and this is T4. And if you remember, our general term is just the same as A into n minus 1 times D. This is where these come from. If we want to express it in sigma notation, all what we do is put in the sigma sign, which is the sign that looks like a very weird E, and we'll always start from K is 1 up until we get to N. And what we put here is our general equation, essentially our TK. So if I was to put that, you will see that we'll have A plus, so we will now use K. It will be K minus 1 times D. So this is how we are going to express our series in sigma notation. So essentially what sits here is our general term. And what you need to understand is that that sigma notation is just the same as what we have been dealing with. It is just the sum of n terms. So because we have n here at the top, that means we are summing n terms. So this means we can use the equation that we always use in order for us to evaluate this. You can use n over 2 into 2a plus n minus 1 times d. Okay, what is here at the top tells us about the number of terms. So with these fundamentals, you should be able to now go and start dealing with questions. Okay, so we'll quickly go now and have a look at our first question and see if we really understand what we have been taught so far. So in order to solidify our understanding, let's have a look at problem or example 1. So what I suggest that you do is to pause the video or download the PDF that we have compiled that contains these problems. Attempt them first and then only come and watch once you are done or if you do not understand something. So let's have a look at this problem. So we are given a sequence which is 7, 12, 17, 22, 27, and so on. So the first question requires us to determine the 7th term. So if we observe carefully, let's put in 1.1. The sequence we have is 7, 12, and then 17, and then 22, and then 27. So we are told that this is an arithmetic sequence. So given that we are told that this is an arithmetic sequence, we need to ask ourselves, what do we know? And what you should know about an arithmetic sequence is that it has a common difference. So the first difference is equal. So let's go ahead now and do our work and see if that indeed is the case. So we can clearly see what our first term is, but remember we're looking for T8. So currently what we have here is the first 5 terms. We're looking for T7. So we have term 1, we have term 2, term 3, term 4, term 5. So we clearly need to find term 6. And then we can now afterwards find term 7. But let's have a look at how we can actually achieve that. So the difference here, 12 and 7, what you should know is you'll get a 5. 17 and 12, you will get a difference of a 5. 22 and 17, you will get a difference of a 5. 27 and 22, you will get a difference of a 5. What we know is that the difference 5 will always be the common difference, which means the term that we have here and here should give us a difference of a 5. So it means when we go in that direction, we just need to add a 5 from what we have. So that means we must do 27 plus 5, and that will give us 32. So 32 is what should be here. But what we know is that the common difference should still be a 5. And how we go there, we take the previous term, we add a 5. So 32 plus 5, that becomes 37. So as you can see, we have found our term 7. So therefore, our T7, as you can see, it becomes 37. So you didn't need to use the formula here because it is only on the next question, 1.2, where we are required to determine the general term, essentially, what is Tn? And we know that generally Tn is a plus n minus 1 times d. And remember that what we were looking at on this row there was d. So we need to ask ourselves, what is a? If you look carefully, we said a is always T1, and our first term here is 7. So we have found that our a is therefore 7. And we clearly can see from our working that if we do T2 minus T1, which is the same as T3 minus T2, the answer we get is a 5. So D is 5. So let's make a note of that. So therefore D is 5. So I can now go ahead and find our Tn. So our Tn will be A, which is 7, and then plus our n, which is, our n, we do not know, so it will be n minus 1, and then multiplied by our d, which is 5. So if you observe carefully, this will be 7 plus 5n minus 5. So this becomes our Tn. So if you look carefully, the 7 and the 5 will subtract, giving us the final answer for Tn as 5n plus 2. So this here becomes our answer for 1.2. Okay, awesome. Then for 1.3, we are told use the formula to calculate the 20th term. So 1.3. So essentially on 1.3, they are asking us what is T20. So essentially, if you observe, you will see that all what we need to do is to take n and make it 20, and then we'll be able to find the answer. So T20 will be 5 into 20 plus 2, which if you observe carefully, it will be 102. Now let's go to 1.4. So on 1.4, we are asked which term of the sequence is equal to 77. So essentially, we are given that Tn is 77, and they are asking us what is the n. Okay, so what is n equal to? So what we are going to do is we are going to use our Tn formula. So if you observe carefully, our Tn we found before is 5n plus 2. And we are going to equate this to 77. And we are trying to solve for n. So we'll transpose that 2. So what we'll end up having is 5n equals 77 minus 2, which will give us 75. And if you look carefully, you have 5n equals 75. So you can easily find your n by dividing 75 by 5. And the answer which you will find will be 15. So it means for our problem, you should see that n is 15. So the term of the sequence which will become 17 or 77, that is T15. So we can say, therefore, it is T15 that is equal to 77. So next we need to have a look at 1.4, which we'll take to the next page, where we are required to calculate the sum of the first 25 terms. So let's have a look at what is happening here. So this is an arithmetic sequence, and we know that for 1.5, they are looking for Sn. What is it equal to? But they say the first 25 terms, which means I'm given that I'm looking for the Sn for n is 25. So remember that our Sn is always given by 2, n over 2 into 2 times a plus n minus 1 times d. Okay? Now we know what a is from the previous workings. If you do look, you'll see that a is 7 and d is 5. So it means we are in a position to find our sum because we actually have all what we need. So the sum of 25 terms will be equal to 25, which is the n, number of terms, divided by 2 into 2 times the a there is 7, and then plus we'll have 25 minus 1 times the d is a 5. So we'll need our calculator to get this done. So if you do use your calculator, you'll see that the sum of 25 terms will just be 1675. Okay, that is what our answer gives us. But what you could have done also, you could have used this formula as n equals n over 2 into a plus l. So in order for us to find l, which if you remember that is the last term, we can use our formula Tn, which is 5n plus 2. But if you look carefully, we are told that we are summing 25 terms, which means the last term is at n is 25. So this means that L will just be 5 into 25 plus 2, which will be equal to, it will be equal to 127. And remember that the first term we already know, which is a is 7. So this means that the sum of 25 terms, you could have said 25 over 2 into the first term, which is 7, and then plus 127. So I'll go and use my calculator and see if I find the same answer. If you look at our calculator, indeed we do get the same answer, 1675. So our answer will be 1675. So both formulas do work. Do you see that? I hope you do. So you can work out your problems using any of the two formulas, depending on which one is convenient for you. But make sure that you are able to use both of them. So this brings us to the end of example 1. Next, we will look at example 2. So next, let's have a look at example 2, and I advise you to pause the video, have a look at the question, attempt it yourself, and see if you will get the same answers. So 2.1. What you should note, as we did previously, is that this is given as an arithmetic sequence. So what we know is that the first difference will be common, meaning it will be equal for any difference of 2 consecutive terms. So we are required to determine T10, the 10th term of the series. So let's go and have a look at how we can get that. So we have -3, 2, 7, and then 12, and then 17, and so on. So what we'll do is we'll get the next set of terms. So what we can see is that if you take the difference, 2 minus -3, you get a 5. 7 minus 2, you get a 5. 12 minus 7, you get a 5. 17 minus 12, you get a 5. So when we take the difference between this one and the next term, we should get a 5. In other words, we just need to do 17 plus 5. So that gives us 22. And then we know that the difference between 22 and the next term is 5. So in other words, you just need to add another 5, and then you get 27, and then it goes on and on and on. To get the next term, we just need to add a 5 on the 27, and that becomes 32. And we can go ahead and have a look at the term following that. So the difference is still a 5 and a 5. We just need to add another 5, and that becomes a 37, like that. Then let's have a look at how many terms we have now. 1, 2, 3, 4, 5, 6, 7, 8, 9. We are missing one term to get to term number 10. So let's go ahead. We know the difference between 37 and the next term should be 5. So which means we need to add 5 on top of 37, which means we are getting 42. And what you should note is 42 becomes our T10. Let me double check. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is correct. So it means our answer for question 1 is that T10 will be 42. Okay, that is our answer. So next, let's have a look at 2.2, where they require us to determine the general formula of the sequence. Essentially, they are asking us what is Tn, and we know that Tn takes the form of a plus n minus 1 times d. So a is the first term, and when you look at our sequence, you will see that the first term is 3, negative 3, and then d is our common difference, which happens to be 5. So what does this mean? It means we can go ahead and find our Tn. It will be negative 3, that is our a, n minus 1 times d, which is 5. And you will see that our answer Tn will just be minus 3, and then plus 5n minus 5. And what you will see is that our final answer, therefore Tn, will simply be 5n minus 8. Okay, that becomes our answer for 2.2. Let's go to 2.3. So for 2.3, they say use the formula to calculate the 25th term of the sequence. So essentially, what is T25? So we are given Tn already, or we found it. So all what we need to do is wherever we see n, we must go and put 25. So we'll have 5 into 25 minus 8. So the answer just becomes 117. So that becomes our T25. Then let's go to 2.4. So 2.4 is asking us which term is equal to 97. So essentially we are given Tn equals 97, and we are asked what is the n value which will give us 97. So we have our formula already, which is Tn 5n minus 8. So it means this 5n minus 8 will be equal to 97. And because we are solving for n, we can just transpose this 8 to the other side, such that we end up having 5n equals 97 plus 8, and that gives us 105. So we are now in a position to go and find n, because it will just be 105 divided by 5. And the answer which we should find, you will see it will be 21. So this means that it is T21 which will give us 97. So it is only when you take 21, put it in our equation, that we are going to end up getting 97. And that is the answer which the teacher is looking for. Now next, 2.5, let's go and have a look at our question. So we are essentially asked to find the sum of 30 terms. The formula we are going to use is this one. Sn is n over 2 into 2a plus n minus 1 times d. So a we already have, it is negative 3. D we found as 5. And n we are given as 30. So it means we have all what we need in order for us to go and determine our sum. So our sum of 30 terms will be 30 over 2 into 2 times our a is negative 3 plus our 30 minus 1 times d, which is 5. Close these brackets. So what I'll do is to just quickly go to my calculator and calculate the sum, and then come back and put it up here. So when I go to our calculator, you'll see that the answer which we end up finding is 2085. So that is our sum of 30 terms. Do it on your calculator and make sure that you do get the same answer and correct wherever we do make a mistake. Let's go and have a look at 2.6, a very interesting problem where they say, express the series in sigma notation for a sum of n terms. Right, let's paste this here and figure out what is happening there. So we are asked to express the series in sigma notation. So there's two things we need to realize. The first is that what we are given there is a sequence. So this here is a sequence, and then a series, all what it is, if we want to convert this to a series, we just put in pluses in between what we were given. So if we take this here and we just put it here, we can make this to be a series by just putting some plus signs in between. So now the question becomes, how do we express the series in sigma notation? And this we have covered previously. I said what you need is to put in your sigma sign, which is like this. And we'll always have k is 1. And then they say we should express this in sigma notation as the sum of n terms. So it means here at the term at the top, I'm going to have n. Why do I have n? It is because they said the sum of n terms. And then what sits here is our general term. Our general term, if you observe carefully, we found it as 5n minus 8. But we don't use n, we use k. So it means it's going to be 5k minus 8. Okay, this here is our general term. And all what we did was to replace n with k. And that would be essentially our answer expressed in sigma notation. I hope you understand, and this really helps you in getting comfortable with sigma notation. And next we'll look at example 3, which further solidifies our understanding of arithmetic series and sequences. So next, let's have a look at this question where they require us to determine T12, and we are given 5 terms. So what I'm going to do is to write this as a sequence. And by sequence, all what I mean is that I'm going to eliminate the pluses because it is currently a series, okay? So I'm going to have 50 and so on. Now let's go ahead and determine T12. So what you should see is that if we take the difference between these two consecutive terms, to move from one to the other one, you subtract a 5. Even for this one, the difference will be negative 5, negative 5, negative 5, meaning the difference between the current 30 and the next term, we must just go 5 less. So what I'm going to do is if we minus 5, we get 25. Minus another 5, we get 20, we get 15. Then we get 10. Then we get 5. Then we get 0. And then we get minus 5. Let's make some space. So all what is happening is we are just minusing 5. It becomes minus 10 and then minus 15. So the difference continues here to be minus 5 between any two consecutive terms. So let's make a note of that. So if you look at our terms now, we can easily extract our answer. So if you observe carefully, we're looking for the 12th term. And if you look at 12, we have minus 5. So this means that our T12 is negative 5. Okay, so when we look at our series, your 12th term will be negative 5. So this just goes back to understanding the first difference. We are using it to spot the pattern. How do you move from the previous term to the next one? We subtract 5 continuously. Okay, awesome. Now next, let's go and have a look at 3.2. 3.2, we are required to determine what is Tn. And what do we know? We know that Tn is always given by a into, or a plus n into, or n minus 1 times d, where the a is always given by the first term, which in this case happens to be 50, and the d is negative 5. Okay, so let's go ahead and put in our Tn. So our Tn will be 50 plus n minus 1 times d, of which d is negative 5. So if you observe carefully, you will see that the Tn will be 50 minus 5n and then plus 5. So if you simplify, you'll see that we'll have negative 5n plus 55. So let's go ahead and have our Tn equals minus 5n plus 55 as our answer. Okay, so let's go now and have a look at 3.3. So 3.3, they say use the formula to calculate the 30th term. So essentially we are looking for T30. So all what we need to do, wherever we see n, we need to go and put in 30. So this means we'll have T30 equaling to our formula minus 5 into 30 plus 55. The answer which we get is, we get negative 95. So our T30 is negative 95. Okay, so therefore T30. So if you do the subtraction which we do, when you get to term number 30, you will see that you will actually have negative 95. So let's go to the next term, 3.4. 3.4 is asking us which term of the series is equal to negative 25. So essentially we are given that Tn is minus 25. And now we are being asked which n value is this. Okay, so what we are then going to do is to take our equation Tn, which is minus 5n plus 55, and equate it to minus 25. The aim here is to solve for n. So we'll transpose that and then be left with minus 5n equaling. So if you look carefully, the 55 will be negative. So when you combine it with the negative 25, we'll end up getting negative 80. And what you will clearly see is that our n will be negative 80 divided by negative 5. And the answer which we do get is 16. So what does this mean? This means that it is term 16 which will give us, or that will give us minus 25. Okay, you can carry on from here. If you do one more, you will see that if you do the subtraction, you will get minus 20, and then do one more, you will get minus 25, which is indeed will be a T16. Okay, I'm glad you understand, and I hope it does make sense. Let's have a look at 3.5. So 3.5, we are asked to calculate the sum of the first 40 terms. Okay, so essentially we're looking for S40. What we need to know is that n will be 40 in this instance. Our a, we figured out, it was given, it is 50, and our d is minus 5. So I can go and calculate the sum of n terms, which we always use the formula n over 2 into 2 times a plus n minus 1 times d. this will give us the sum of n terms. So let's go and substitute the numbers which we have. So let's have a look at what our S40 gives us. So we'll have 40 over 2 into 2 times our A is 50, and then plus 40 minus 1, multiplied by our D, which is negative 5. So I'll go to my calculator and punch this and see what we obtain. So if you look at our answer, it will become negative 1,900. So let's go ahead and put in our sum, which will be negative 1,900. So that will be the sum of the first 40 terms. And then next, we are required to express this in sigma notation, which should be very easy because we already have our general term, which is Tn. Okay. So all what we need to do is to just say in sigma notation that 50 plus, let's quickly note them down. So these in sigma notation will be, we'll put in our sigma notation sign, and we'll start from k is 1. Please note, they said we should do the sum of n terms, which means at the top here, I'm just going to have n. Then remember what sits here is the general term. So remember for our general term, we found Tn becomes negative 5n plus, let me confirm, plus 55. So this is what we found as our general term. So when we come here, all what we do is we replace k with n. So it becomes negative 5k plus 55. And this is what the teacher is expecting us to understand. I hope this does make sense. Let's have a look at another example, example 4. Okay, let's have a look at example 4, where the question reads, consider the arithmetic sequence written in sigma notation. We're given that. The first question requires us to write the general form for the nth term of the series. So let's go ahead and have a look at 4.1. So there's a couple of things that I need you to remember. The first is that whenever we are given a sigma notation and k starts from 1, very important that this is the case. If k starts from 1 and we end at n, whatever that sits here, that becomes our general term. So it means our tk, looking at the problem, is just 3k plus 1. And remember, what we do when we move to sigma notation, we always replace n with k. So now I'm going to do it the other way around, where I'm going to take the k and replace it with n in order for us to find our Tn. So therefore, our Tn for this expression will just be 3n plus 1. So that is what we have. And then 4.2, we are required to write the first 5 terms of this series here. So it means what I need is T1, T2, T3, T4, and T5. So I'm just going to use the equation in order for us to determine these. So we have our Tn, which is 3n plus 1. So it means if I'm looking for T1, it will be 3 into 1 plus 1, which will give us a 4. And then if I'm looking for T2, that will be 3 into 2 plus 1. That will be a 6 plus 1, which will give us a 7. Then if I need T3, it will be 3 into 3, which will be a 9 plus 1. That will give us a 10. Then if I go for T4, because remember they said the first 5. So I'll have 3 into 4, which will be 12 plus 1. This will be 13. So let's go ahead and have T5, which will be 3 into 5, which will be 15 plus 1, this will be 16. So now, how do we present our answer? They said the first 5 terms of the series. So our answer should be presented as a series. So term 1 is 4, so that means I'm going to have 4 plus 7, which is term 2, plus 10, which is term 3, plus 13, which is term 4, plus 16, which is term 5. So they are just separated by this plus here to indicate that what we have here is a series, and so on. So it carries on, but they only ask us to find the first 5 terms. And then next we are asked to calculate the 15th term of the series. So let's go ahead and have a look at 4.3. So in 4.3 we are asking ourselves, what is T15? This should be very easy because we actually already have our general equation. So we'll just plug it in. So T15, wherever we see n, we'll put 15. So 3 times 15, that gives us 45. 45 plus 1, that becomes 46. So therefore, our T15 is 46. So next, let's have a look at 4.4. So 4.4 is asking us which term of the series is equal to 64. So essentially, we're given a term that it will be 64, but we are not sure what the n is there. And how we're going to find that is using our general formula, which is 3n plus 1 equals 64. We need to solve for n. So we first need to go and transpose that 1 there, such that what we end up having is 3n equals 63. And you should be able to see that your answer will be 63 divided by 3, which will give us 21. So what can we say? It is T21 that will be equal to 64. And that becomes our answer. So the next question, 4.5, is asking us to evaluate the sigma sign for n equals 100. So we need to understand, if you make n to be 100, all what that means is we are finding the sum of 100 terms. That is what it means, because 4.5, look at how our sigma notation is. So we're starting from k is 1 up to n, and we have 3k plus 1. So now all what they are saying is that n is 100. What that means is that we are looking for the sum of 100 terms. So, and remember I said your sigma notation is just the same as the sum of however number of terms which you have there. And remember, we are still working with our arithmetic series. So it means our Sn will just be n over 2 into 2a plus n minus 1 times d. And remember, previously we did find our a, or in fact, if we do want, we can. Our a, remember, is the first term, and the first term we found is 4. And whatever term that usually multiplies the n is our d, okay? But you can go and double check that and say 7 minus 4, you will see that you will have d. So our a is 4 and our d is 3. So we can go ahead and find the sum of 100 terms, which is what our sigma notation will be equal to. So we'll have 100 divided by 2 into 2 times a, which is 4, plus we'll have 100 minus 1 times d, which is 3. So I'll go to my calculator, quickly calculate this and see what we obtain. So when using your calculator, what you will find is that your sum of 100 terms is 15,250. So what this means is that our sigma notation there which is from k is 1 up to 100 of 3k plus 1, what it amounts to is 15,250. So that becomes our answer, and our teacher is going to be very happy because we seem to understand what we are required to do when we have our sigma sum or sigma notation. I hope this does make sense. Pause the video, try it by yourself, and make sure that you do understand what we are doing here. So next, let's have a look at example number 5. So next, let's have a look at example 5. So we are told to consider the arithmetic sequence, which is 8a, 20b, 32, and so on. The first question requires us to determine the common difference of the first of this sequence. So let's go ahead and quickly note down the sequence which we are given. So what I need you to remember is that the first difference of an arithmetic sequence is equal. So we are going to use that principle to eventually attain the answer, or to get the answer. So now let's go and use the fact which we noted above, which is that the first difference is constant. So this difference here will be a minus 8. And that difference there will be 20 minus a. And then this difference here will be b minus 20. And this difference here will be 32 minus b. So what do we know? All of these should be equal. So I'm going to deal with the pinks first because I will easily be able to solve for a. So essentially what we have is a minus 8. That should be equal to 20 minus a. So we can transpose the a to this side and take the 8 to the other side. So we'll have 2a equals, if you look carefully, 28. And I can easily find our a by just doing 28 divided by 2, which will give us 14. And remember that these are equal because both of them are equal to d, which is the first difference. So as you can see, we have actually found d because d is just a minus 8. But we have just found that our a is 14, so which means our d will just be 14 minus 8. And 14 minus 8 will give us a 6. Okay? So we can go ahead and find the other part and determine b. And for b, we can, do it very easy because we know the difference already. So we can do that b minus 20, and then we can clearly see that our d, which is 6, it will be 6 equals b minus 20. And if you think carefully, our b must be 26 in order for this to work. So there we go. We have found our b and we have found our a and d. But what they were looking for, most importantly, was d here, which we just found as 6. Okay, so we really didn't need to even find the b. So let me eliminate it because on the next page, we actually need to find these. So if you look at the next question, 5.2, they require us to find a and b. And how we should find them is by using the common difference, which is what we have found. So that d there is our common difference. So looking at these difference, we can clearly see that d should be equal to a minus 8, and also d should be equal to b minus 20. So d we have found is 6. So I have 6 equals a minus 8, and I have 6 equals b minus 20. So we can just transpose these to the other side, and you will easily see that your A should be 6 plus 8, which is 14, and your B should be 6 plus 20, of which for B we will get 26. So these are our answers. So therefore our A is 14 and our B is 26. So these are the answers which we were required to find. And then the next question becomes, derive the general formula for the sequence. That is 5.3. So essentially we are asked, what is Tn? We know that Tn generally is A plus n minus 1 times D. And guess what? A we have, which is the first term. A, which is T1, that is 8. And then the constant difference, which is found not long ago, that it is 6. So let's make some space and calculate Tn. So if we substitute, you will see that our Tn will be equal to our A, which is 8, plus n minus 1 times our D, which is 6. So this will end up being 6n minus 6 plus 8. And what you will see is that our final answer for Tn will end up being 6n plus 2. Okay, that is what we were required to find. Let's go to the next page and have a look at 5.4, where we are required to determine the 12th term of the sequence, essentially T12. So let's have a look at it. This one. So 5.4. What we are trying to figure out is what is T12. So we already know what Tn is. So Tn is 6n plus 2. Let's double check. That is correct. So whenever we are looking for T12, what that means is wherever we see n, we go and put in 12. The answer you should find is 74. So what does this mean? It means that T12, or the 12th term of the sequence, if you carry on, you will see that it will be 74. Okay, let's go and have a look at 5.5. So 5.5, we are asked which term of the sequence is equal to 92. So essentially, we have Tn equals 92. And now we need to figure out which n is this. So for this, we are going to use our equation. We are given that Tn is 6n plus 2, of which this will be equal to 92. So we'll just transpose this 2 to the other side, such that you'll end up having 6n equals 90. And then you can see that we can find our n by just dividing 90 by 6. And the answer which we obtain is n is 15. So what does this mean? This means that our T15 is 92. And this is what the teachers are looking for. And I hope this does make a lot of sense to you. So pause now and then and attempt these questions by yourself. So this is 5.5. Okay. And then next, we are asked to calculate the sum of the first 15 terms of this sequence. So very easy question. Let's go ahead and ace it. That will be 5.6. So on 5.6, all what we are looking for is the sum of 15 terms. So essentially, we are given that n is 15. And remember, previously we did do the working. So your D is 6. And let's go and double check your A, which is the first term, that is 8. So A is 8. And remember, your sum of n terms is n over 2 into 2a plus n minus 1 times D. So we know the N, we know the A, we know the B, the D, so we can go ahead and find our sum of 15 terms. So it will be 15 over 2 into 2 times 8, and then plus 15 minus 1, multiplied by D, which is 6. So I'll go to my calculator and quickly punch this and see what we obtain. So the answer which you should obtain if you punch this on your calculator should be 750. Okay. And lastly, if I can add a bonus, if we are required to express this in sigma notation, the sum of 15 terms, all what we would do is would have k is 1. Then at the top have 15. Then remember what sits here is the general term. So our general term is 6n plus 2, which means we would make it 6k plus 2, and this would be equal to 750. And this, your teachers would be extremely happy because this demonstrates that you understand the sigma sign notation. So I hope this does help, and it's a good enough introduction for you to be able to start working on question paper questions. So what we are going to do for the remainder part of this course, at least arithmetic, is to select question papers from various papers over the years and see if we can even gain a better understanding. But I hope this lesson has helped you to have a good base and a foundation of what you should do. So let's quickly go back and have a look at what you were supposed to take out of this course. So if you look carefully, it's 5 things. Understand the fundamentals, work with terms of a sequence, apply summation techniques, develop problem-solving skills, and demonstrate mastery through applications. These outcomes we have ticked, and we will practice further by using past paper questions to even see variations of other questions. For now, we'll pause here. Thank you, and you can go ahead and look at past paper questions. Cheers.